Hello, me BC peeps. We shall be doing 7, 8, and 9 on this video. So I've already taken the liberty to set up a sub n plus 1 divided by a sub n, and we will do the canceling together. So if you look, the x minus 1s, the top has 2 more than the bottom. So when we cancel these out, everything will be canceled except for 2. If you look at the 6 to the ends, the bottom has an extra 6. So we will get something that looks like this. But in the ratio test, we need to take the limit. We have to find r, which is the limit as n goes to infinity of the absolute value of the answer we just found. But you'll notice this does not have any n's in it. It's just constants. The x will be the values that you are testing to see if it converges, so it'll be a constant for each value of x. So this will be just x minus 1 squared over 6. And we know that in the ratio test, this r must be less than 1 in order for our series to converge, so we set less than 1. At this point, we'll multiply both sides by 6. And we shall square root both sides. Now, we're pretty much done. This here is our ratio, or our radius of convergence. We know that it has to be within radical 6 of 1, where 1 is the center. But for fun, we can go a little bit further. So we can put negative radical 6 and get rid of the absolute value. And you could add 1 to everything. So that's getting more our interval of convergence. I'm not going to test the endpoints, but we'd have to, but we're done. The radical 6 is the answer for number 7. So the answer is B. Let's use a pretty color. B is the answer. All right, let's move on to number 8. So this one's kind of crazy. It says it has a horizontal tangent line and an inflection point at the same value of x. So to have a horizontal tangent line, the derivative would have to be equal to 0 because the slope of a horizontal line is 0. So we need to take the derivative of this and make this equal to 0. So y prime, the derivative is 4x cubed plus 2bx plus 8. And that must be 0 to have a horizontal tangent line. Next, having a point of inflection, the second derivative would have to change signs. So let's find the second derivative. 12x squared plus 2b. And in order for the second derivative to change signs, it has to be 0 at the point where the sign changes. So we have to set this equal to 0 also. Now I will factor a 2 out. Therefore, 6x squared plus b must be 0. I'm going to solve for x, subtract b from both sides, and then divide both sides by 6. And square root. So that we know x has to be that number. Now, this has to be a real number. So therefore, the number inside, that must be a positive number. To be a positive number, b would have to be negative. So now we have narrowed down our answer choices. So B has to be negative so that this will come out to be a real number. we're left with b is -6 or -1, because those are the only answers left that match this. So let's take a look at our y prime equals 0 statement. Now, we're going to do a trial and error, basically. So if b were -6, and I plug it in to this formula, I would have positive 6 over 6, or plus or minus 1. But if b were -1, plugging into the same formula, I would get 1/6. So, I don't know, you can believe me or not, if you were to plug this in for x and 1 for b, you're not going to get 0, because you're going to have square roots of 6's. It just ain't going to happen. So let's plug in our 1. So we'll do the x equals 1, b equals -6 into this equation right here. So when I plug that in, I'm going to get 4 times 1 cubed plus 2, b is -6, x is 1, plus 8 must be 0. Whoa, that was weird. Must be 0. So 4 minus 8 plus 8. Oops, that doesn't equal 0. Oh, 12. 6 times 2 is 12. Again, don't do drugs. So that is a true statement. So b must be -6. The answer has to be A for number 8. So we're good with that one. One more to go on this video. We are on number 9. So we have the differential equation, dy dx equals y minus x. And we know we have the point 5, 1 is a solution. And we want to approximate, so I can say f of 5 equals 1. We want f of 6, that is a question mark. But we want to do Euler's, and the step is a half. So if our step is half, or delta x is 0.5, to go from 5 to 6, clearly there's 2 steps. So that's pretty straightforward. So we're going to make a table with x's and y's. Then we're going to have a delta x, then a dy dx, and then if you multiply those two, that will get you a delta y for our approximation. So we start with 5, 1 is our starting point. Our delta x is always 0.5, so I'm going to go ahead and fill that in. And if delta x is 0.5, if you add 0.5 to 5, the next one will be 5.5. And if you go again 0.5, the last one will be 6. So to find dy dx, we have to plug 5, 1 into dy dx. So dy dx at 5, 1 is 1 minus 5, -4. Multiplying our delta x times dy dx, we get -2. That means our y decreases by 2. It was 1. 1 minus 2 is -1. All right, we need to find the dy dx at this new point, the slope. That's where xy equals 5.5 and -1. We plug that in, -1 minus 5.5. That's going to be negative 6.5. And then we need to multiply that by 5. That's negative 3.25. And again, our y decreases by 3.25. It was negative 1, so that's negative 4.25. So this says our approximation for 6 is negative 4.25. That would be an answer of A. And my answer sheet here says A. And that's it for this video.